Hello, I'm Sarah, and I'm the Director of Growth Marketing here at Prefect. I'm really excited about how we can show you how to build a resilient data platform. Here we go. I'll be addressing any of you who write Python and want to deploy your workflows to prod in a resilient and scalable way. If you're a developer, it doesn't matter if you're coming from raw Python scripts, Airflow, or anywhere else. What we're doing here is we're turning a Python script that analyzes MLB game statistics into a production-ready workflow. You can follow along in the dev day zoom out repo. So for all the tracks and sessions, you can find all of the code here in GitHub. Go ahead and navigate to the repo. I'll assume a setup environment, so you'll need at least Python 3.12 and a Prefect Cloud account. Head to app.prefect.cloud to sign up if you haven't already, and then follow the README in the GitHub link I shared. Make sure to follow the README and set up a new virtual environment. That's going to be really important. Then you'll be all set with all the dependencies you'll need to follow along. Let's talk about what we're building now. In the repo, you'll see an MLB flow script. Our script fetches MLB game data, as I mentioned, analyzes it, and generates reports. It's a common pattern I'm sure you've seen. Extract data from an API, transform it, and load it somewhere else. But running this as a bare Python script has limitations, right? We see a bunch of functions, but no visibility into its execution, no built-in error handling, and no easy way to schedule or trigger runs on remote infra when you need it. Additionally, it's hard to maintain as complexity and dependencies grow. So the MLB script, right, is a classic example because it has, if you scroll through, external API calls that could fail due to unexpected reasons, data transformations that need tracking, results here, we see we're opening files, right, that need to be stored, and analysis that should be cached for efficiency. Prefect helps solve these challenges by adding orchestration capabilities while keeping your code Pythonic. Everything stays in Python, no YAML, no DSLs, just Python with some helpful decorators. Now for the actual code. What you'll see is a basic Python script with functions which shouldn't be new to any Python user. What you'll also see, though, are task and flow decorators on top of the functions. This is Prefect. This is where Prefect comes in. With these simple decorators, when you run the Python script, Prefect Cloud will know exactly what's running and its status at any given time. So let's run it. As it runs, we can see the task graph. This is a visual representation of your workflow, updating in real time as your tasks run. Task states are represented in the colors you can see and alert on failure quickly. More importantly, the dependencies between the tasks are not only visualized, but deduced automatically from the Python script itself. So this was a successful run. What would it look like if there's a failure? Let's throw an exception to imitate that. So in one of our functions, I'll just divide by 0, right? That happens sometimes. And then we're going to run the script just like we did before. Before we navigate to the flow run itself, let's take a look at all of our workflows in aggregate. Oftentimes, teams have SLAs around total lateness or failure rate. Release into beta, the all-new runs page allows you to answer those questions for your team easily. Even if you're a data platform team that what you're doing is really supporting multiple other teams running workflows, say an analytics team, an ML team, for instance, you can measure SLAs separately using tags up here. The Prefect Runs page allows you to ensure your team can accurately report on SLAs upwards throughout your organization, whether it's to your manager or your manager's manager. Now, that run that we just kicked off, this individual flow run page is mostly built to mitigate failure. You don't usually wake up in the morning, look at your flows and say, everything is fine, and then continue exploring for minutes or hours, right? Right. So when we navigate to the task that actually failed down here, The error in the terminal, right, is represented in Prefect Cloud. This is to enable anyone to debug the workflow, not only the person who has access to the terminal run. You can see the summarized log, the full stack trace, and of course, all the dependent tasks running before it. Of course, this is a fake error, but if we were really debugging, we can go into the task running just prior to see what file was being cleaned in case it was corrupted. The individual run page allows you to get to the root cause of failure faster. Now, so far, we have been kicking off the workflow from our local terminal. What happens when you want to, say, run it on a schedule? We can account for that with a deployment. Now, we'll be talking about deploying workflows. When we go back to the script, if we scroll to the actual main section here, so speaking broadly, you might be thinking, I can just run my Python script when I want. Why do I need a deployment? Why are we talking about deploying workflows? First, you need to think about scheduling and infrastructure. We need a deployment to run a flow on a schedule and run it remotely on infrastructure, usually cloud infrastructure these days. Additionally, we've been running the MLB data on a particular day. You need to add parameters, right? To be able to pass in any team ID or any date from the UI without having a local setup. To do that, we'll need a deployment. Additionally, sharing the flow run results with teammates, as we just mentioned with the failed run, for example, requires a centralized place for them to be run and tracked, which is using a deployment. How we do this first is by adding a .serve method in the script itself onto the main function, just like we have here. It's the quickest way to create a deployment. With this one function, we can pass in default parameters, even a cron string for a schedule, but behind the scenes, this creates a deployment in Prefect Cloud and starts a local worker process. So what does that look like? We're going to run the script just like we did before. But what you'll see is the output is a little bit different. When we go into the deployments page here, you'll see we have a deployment that we just created. With the cron string, we have scheduled flows once an hour. We have deployment specific metrics now, like duration and success rate. And we can track SLAs at the workflow level across all the runs for that workflow. To run it, we can either wait for the scheduled run or run it ad hoc from the deployment itself. Now, when we quick run, we can change any of the parameters, whether it's the team or the date, and run it. This is not where the road ends, however. There are a few limitations of the .serve method. So .serve runs in a local terminal process. Your machine needs to stay on, and this does not solve the run it when my laptop is closed problem. The solution to that is deploying the workflow on remote infrastructure with the .deploy method, which will be covered in some of the next sessions. Infrastructure, right? Not only does a local process limit your laptop needing to be on, but what if you want to run different flows on different infrastructure, making sure only the memory-intensive workflows run on expensive infrastructure? This is solved by passing in a specific work pool into .deploy, which is Prefect's way of mapping specific flows to dynamic infrastructure that you create. That might be different between an analytics and ML team, for example. Thirdly, scheduling. We passed in a basic cron string, but what if you only need to run the flow when a new file with stats is present? That doesn't always happen once a day. There aren't MLB games every day. Well, maybe there are. Instead of wasting resources checking for the file on a regular cadence, you can set up an event trigger with automations for the deployment. All of these complexities get back to the reason why workflow orchestration goes far beyond scheduling. Simple, redundant scheduling will put your team in trouble when it comes to maintaining SLAs and therefore trust externally. Additionally, not accounting for various infrastructure types will have you spending far more on infrastructure than you need to be. Our customers, like Endpoint Financial, reduce their data platform costs by 73% this way. With that, you're set up with the first steps of deploying your workflow. But there's so much more. Thank you so much for tuning in.